We are working limits in calculus and evaluating limits analytically, and we're over here in section or button on button 9 here. We have two functions, h and g, and we want to find the limit as x approaches 2 of g composed of h of x. Now there's a couple different ways we can do this. However, we're going to follow a theorem, and we're going to solve it using a particular theorem. Alright, so we have h of s equals 10 and 3, so let me write this out. We have h of x is equal to 10x plus 3. What's the other one? G of x is equal to 3x minus 3, and we're asked to find the limit as x approaches 2. We're doing g composed of h of x. G composed of h of x. Now we could find g composed of h of x right here by taking this 10x plus 3 and substituting it in minus 3. Simplifying all that down and then plugging it in here and doing it that way. However, we're going to state a theorem instead, and that is we're going to let g and h be functions. Okay, we're going to let g and h be functions, and we're going to take the limit as x approaches c of h of x, and we're going to say that that's equal to L. I'm going to write an and statement here. The limit as x approaches L, okay, of g of x, and we're going to say that's equal to g of L. Alright, so we're going to assume that to be true, and now we can say that the limit as x approaches c of okay. So this is how we're going to solve this particular problem here. We're going to use this theorem right here. We're going to be taking taking the limit of h of x first, and then taking that number and just plugging it into g of x. Right? Because according to this theorem, that states that's what we can do. And I'm going to come right over here to the help where I've already done this actually. So first we find the limit of h of x, and we did that by doing direct substitution, just plugging 2 directly in. And then once we got that number, we just plug it directly into g of x and get out our answer, which is 66. All right. So that's all you have to do.